Okay.
How are you?
Okay. So yeah, I'm going to talk a little about some of these issues from a bit of a planning perspective, but actually, obviously, I'm going to try respond to the bunch of things that Jeff brought up. In fact, one of the very first questions that Jeff was worried about is what if, in fact, we do need to make sure that this collaborative AI is in something that's already been done. That I can assure you, Jeff, that we don't have to worry from at least AI perspective. AI folks have mostly, non-AI folks, people who are into humans, such as Karen, maybe, but the engineers never really cared about humans. And so AI had this curious ambivalence to humans. We are much happier on the Mars, are basically beating the crap out of the various of the humans in various competitive sports. So collaboration with humans is something that's surprising to AI people. I understand things have changed very quickly in the last couple of years. AI has discovered humans. There are human X AI, millions of these variations. There's some, my tongue-in-cheek Devil's Dictionary definitions of the different human X AI things that in case you ever want to see them. But it's clear that it at least became politically very correct to say we are into human-like AI, human compatible AI, human in the loop AI, human aware AI. The definitions are worth seeing because they've been tweeted already out. So I have to say that I discovered humans not as far back as Karen, but certainly much earlier than it's become cool. We've been talking about how AI systems should be working around humans, human aware AI systems. I gave a talk back in 2018 as a AAA presidency address. There's a challenges of human aware AI, which is an AI magazine, and more importantly, thanks to the money that Jeff and Tom and co have given, we have already also written a book on explainable human AI interaction from a planning perspective. It's still not done in terms of what collaborative AI is, but it obviously has some common, goals with the bigger aim of collaborative AI. So coming back to the collaborative AI working definition, I'm just feeding this back to Brian. Basically, the stuff on what we want collaborative AI to do is to cooperate, coordinate, and communicate, and that there are these 4 different aspects we need to think of: modeling interactions, modeling collaborations, collaborators, modeling tasks, and knowledge representation. Well, it turns out that at least in our own work, we've been looking at pretty much all of these aspects, at least in the beginning stages. So I can sort of walk you through various of my papers. But as Brian, when Brian and Dina called me up, he so very dedicatedly put it, Rao, you have crap load of papers. Can you give me some bullet points? So Brian, some bullet points for you. So collaborative AI interaction for decision support. I think this something came up yesterday too. It'd be useful to at least say, here is the specific setup of scenario that I'm looking at. You may be looking at other scenarios, and then with respect to that, I'll try to describe to you what sort of aspects of collaboration are relevant and what are the challenges in making them happen. So I basically consider mostly decision support, either embodied or software systems working in conjunction with humans. This setup does conform to this Jeff's conception of collaborative AI that he was mentioning. The machine expects advice and offers explanation help to humans. So both of them, neither of them are at the top of their, neither of them are omniscient necessarily. So they might need help from each other, and they might also provide help to each other. That's the setup that I have in mind that we be looking at. So with respect to that, here is a set of challenges, and I want to flash this first and then walk you through a bunch of vignettes and then get back to this slide again. So the challenges to me at a high level, some of them may not make right away any sense to you right now, but let me just walk through them. So I think the main big challenges in collaborative AI, that is AI systems working with humans, is the mental modeling, acquiring, sensing, and using the mental models, common ground vocabulary and concepts. How do you acquire them? How do you expand them? How do you translate what you're thinking into the common vocabulary? Because that's the only way you can work with others. That's communication. And then this also involves the explanations as for your decisions, if people want to know about that. Taking advice from others in terms that humans feel most comfortable with. This is something that, is another kind of a lesson of what Karen was talking about yesterday. Humans hate giving advice at the level of pixels and step-by-step small steps for the machine. So we should not be, the whole point of AI should not be that we will lose any happiness in our life and spending joyless existence, kind of joysticking machine. So we should be able to provide advice to them in high level, and they should be able to take that into account. As Pat was pointing out yesterday, this is one of the original dreams of AI. John McCarthy basically talked about advice taker program, and we still haven't gotten there, and we hopefully will be required very much for the collaborative AI. If you are collaborating with humans, if you're an AI system, you better take human limitations into account. Assistance should be on point and should be seen to be given, rather than saying there's Wikipedia. And it's also be that when you're providing assistance, you should also make sure that they're actually paying attention to the assistance you're providing. When I say you, the AI system, assistance should take human sensing and computational limitations into account. Otherwise, it's basically useless. And then finally, a whole bunch of this thing is connected, despite the fact that I know Jeff is worried about getting too much into trust. Really, you can't get away from trust at some level. If humans are working with machines, if humans are working with any teammates, they need to think about whether or not they trust them. And depending on that, a whole bunch of us basically just stick around without working in teams because we don't trust anybody else and their competence. So you should be able to get to a way of an AI system should be able to engender trust in the humans that they're working with, and then use that to kind of leverage the collaboration. These are the big ticket challenges. And so what I'm going to do now is to go through these vignettes in terms of the humans working with an AI system, like a planner in this particular case. And in each of these slides, basically it's the same sort of a setup. On the top, you have which of the 4 themes are being talked about. The ones in yellow are the ones that we're talking about here. In the bottom, very bottom, there is like a paper or 2 from our group that you might be interested in looking at. But the bigger thing is the open challenges. What else is left in doing that sort of a thing? So coming back to here, by the way, my patron saint of collaborative AI systems is Corporal Radar O'Reilly. He's from MASH, for those of you who are old enough, who actually provides assistance very well to Colonel Potter. So we always used Radar as the name for our systems. But anyway, so here is a situation. Here are some parts of the plan for our task. So this is a mission planning task. Imagine there is a common interface and the humans are essentially making part of the plan, and the AI system is supporting by completing it or providing critiques and so on. So here are some parts of the plan, and then basically the planner can do obvious things like validating the prefixes, and then it can also provide corrections to your plan and alternative suggestions. This stuff is reasonably obvious. We can do this. Now, of course, even in these challenges, actually, we want to make sure that there's scalability. You should be able to give back suggestions, fast enough so that this, the collaboration is smooth. And then one other thing that becomes important as we go forward is learning accurate human models. When you're providing suggestions, you kind of have a sense of what is the overall problem they're trying to solve, so that the suggestions that you're providing are to the point. Here is another scenario where the machine and the human are looking at the same task, but they may have differing representations. And so one of the interesting questions would be, how does, for example, the machine show the planner, the AI system show a representation of its search space in particular, not at the level of nuts and bolts, but at a high enough level that the humans can say, no, this is the type of region that we are looking at for the plans. So that would be providing like a common interface for the search space. This becomes a subset of a bigger problem that I'll be talking about, which is establishing common ground becomes a very important challenge in collaborative AI systems. Here is a third in the same vignette where the dialogue has gone to a point where the human says, okay, give me an alternative plan. So the planner provides one. then the human starts worrying, why did you suggest these actions, not these other actions? So basically, you are questioning each other in terms of why are you providing these kinds of suggestions. And so this brings up this whole issue of file-based explanation. So you have to provide a reason that the humans can understand as to why the suggestion that you provided is better than theirs. And whenever you're providing explanation, that opens up a dialogue for either human improving their model of the machines and on the task, or the machine improving its model of the task, because the human can come back and say, no, your explanation is actually wrong. In fact, this is the reason you think that your decision is better is actually wrong because of the following parts of the domain are my preferences. So this becomes very much a part of the, as Jeff was talking about, I mean, this has to be part of a dialogue, and the dialogue can actually steer the human and the machine towards more aligned models. So here the open challenges are again learning accurate human models and trying to make sure that in fact, when you're providing explanation, when the machine is providing explanation, are the humans, essentially trusting the machine enough to comply with the changes it is providing about the domain model? This becomes relevant to the trust aspects again. Next, basically, things become much more interesting. Up until now, we were talking as if there is some sort of a common vocabulary, at least the models might be differing in terms of preconditions and effects of the actions, etc. But there may be at least a common vocabulary. But oftentimes, in particular, in the current day and age of deep reinforcement learning systems, learning from pixels about how to do decisions on some various tasks, even though mostly they seem to be currently still playing the board games and Atari games, that is an aspect that we do have to consider, that the AI systems will be learning their own representations and they don't actually have a common vocabulary in which to talk to the humans. And I think collaboration requires common vocabulary. In fact, humans must have invented language. I wasn't there when they invented it because they didn't have USB connections between their brains. And so they had to actually figure out, even though we may very well have very different representations of the world in the beginning, we invented language to essentially symbolically communicate. And the machines who are coming into the world have to do that. And so, in essence, the machine has to be able to translate its explanation from its reasoning to a reasoning that the humans can understand. Karen pointed out yesterday, for example, some of the current status of explainable machine learning. It is sorry state, because explainable machine learning involves sort of painting, annotating a part of the picture and say, this region is the reason why my decision actually was made. And if it's bad enough, pointing explanations essentially are the most primitive kinds of explanations. We essentially have gone much beyond that. And in fact, pointing explanations don't even work at all. They're not even feasible if you're trying to point about a reason for your decision in a sequential decision-making problem. Because if you ask, Ra, why are you wearing this particular shirt today for giving this talk, then I need to show you a little video of my life preceding this particular moment and then put, sort of annotations on that. That's just way too costly and way too cumbersome. And if I start doing that, you will stop asking me questions after that. And so importantly, the humans basically should be getting explanations, of course, multimodal, but definitely they should have explanations in the symbolic vocabulary, where the symbols are things that humans understand. And so the machine has to also learn the grounding for those symbols. So their vocabulary reconciliation, extending the methods to more general explanatory queries, and learning models of the task become like the task open challenges here. A related issue is when you're giving explanations to the human about your decisions, the other possibility is the human is actually teaching the machine, providing advice. This is something, again, Karen was talking about how humans teaching, Karen Fay was talking about how humans were teaching a reinforcement learning system. We actually have a paper. The previous one was a paper in ICLAIR, and this one is a paper in Neurips, which last year, it's a spotlight paper. And that essentially looks at this issue of how do humans in the loop improve the performance of a reinforcement learning system, either by providing it better dynamics of the world because they know the world, or more importantly, providing more information about their preferences, which only they know. And so they should be able to provide it to the machine. And in these cases, again, the explanations are much better for the humans to provide at a higher level symbolic means. And so, in fact, in that paper, actually, we wind up providing not only why the action, but provide an explanation for that action in terms of the objects, which then the machine might very well convert itself into some saliency regions. But any saliency region painting you want to do, the AI should do. You should let me speak as much as possible. So that's kind of very important for collaboration to be smooth. So and of course, in the work that we did, we were just scratching the space of, being able to provide the explanation at the object level. But in fact, really, you should be able to provide natural language advice, the kind of thing that I think, Pat was saying in many of his comments in the chat too. And, natural language is AI complete to some extent. And, it also is a question of how do we make sure that the grounding between the concepts that are being discussed by the human are actually aligned with the grounding that the machine has learned. So that's a very big challenge that is quite relevant as far as collaborative AI is concerned. In fact, one of the other interesting things is people talked about imitation learning, people talked about demonstrations, etc. Even when people are providing demonstrations without opening their mouth, they're actually providing demonstration of how to do a task. You tend to when other people show you demonstrations, you tend to parse those demonstrations in terms of the potential symbolic concepts that they might be possibly likely to be teaching you. And so that sort of reduces the ambiguity of demonstrations. All demonstrations are hugely ambiguous in terms of what it is that you can learn from them. And so, there's some work that we have in this AAAI this year, which looks at the same sort of common ground, how it can be used to reduce the ambiguity in essentially continuous demonstrations by the humans. And that's also kind of going to be important in the context of collaborative AI. Now, I want to take a small digression here, since I basically pointed out this thing about the common ground, and say that collaborative AI systems must, they can be lots and lots of things, but they must better be explainable and advisable. And the explainability and advisability must be in our terms, the human terms. We shouldn't be in the business of debugging the AI systems. If my life of collaborating with an AI system is that I'm debugging that system at the level of its decisions, at 22 decisions, nobody wants to collaborate with those kind of systems. I think that's very important to keep in that mind. And then so that's where this sort of common ground, symbolic lingua franca, for example, would be quite relevant. I think that's something that you could look at. And again, as I said, pointing explanations are actually quite hard to comprehend. The kind of, I will annotate some regions of the space-time signal tube and hope that you will understand my reasons as to why I did what I did, is what we presumably did when we just got out of being primates and started being humans. And then we thankfully invented symbolic language. And so our machines, which will be living with us, better have this sort of a common ground. And it doesn't have to be at the full on language level, but in fact, we may well be able to talk about a domain-specific vocabulary, for the task-specific vocabulary, for which the machine learns the grounding and uses it in taking the advice as well as providing its explanations. One other thing related to this came up yesterday, and I want to bring it up. Part of it is I'm hoping that we're teaching each other about where things are going in AI and collaborative AI. Neurosymbolic AI is a term next only to the human XAI that's been bandied about around, and people see very, very different things in them. There are at least two orthogonal, very different potential motivations. One is the internal symbolic reasoning. There are people, maybe Gary Marcus is, for example, one of them, who think that, in fact, AI systems would need to employ internal symbolic reasoning for efficiency and scalability. The jury on that, they may well be right, but the jury on that is very much out. But the symbolic communication interface is another reason why you may want a neurosymbolic approach to AI. That is, irrespective of the way the machine reaches its decisions, whatever it is using, whether it's using learned representations, it needs to communicate with humans who unfortunately don't have any USB connections to their brains in terms that they can understand. Of course, multimodal, but one big thing that we do in communicating with each other is symbolic language, and that needs to be supported. And it's actually useful to understand that if, in fact, machines were to develop their own symbols internally to improve their internal symbolic reasoning, they may not necessarily make sense to humans. They're not required to make sense to humans. So there are two very different reasons why you might need neurosymbolic AI. But I'm actually talking about the one on the right, which is symbolic communication interface. That I think is pretty immediate as soon as you have human in the loop trying to work with machines, and they want to have their own life instead of just debugging it. So this actually was a blue sky paper, which by definition, blue sky paper is, here are all the challenges, you guys worked on it and cite my paper. And that's what we presented at AAAI 22. And so that actually contains a bunch of higher level challenges here in terms of establishing this kind of a common ground, including concept acquisition, concept grounding, and vocabulary expansion. In fact, I think this came up yesterday. When machines are trying to teach humans, they may have to expand their vocabulary. This is happening already in the AlphaGo, where that infamous 33rd move, there is no way the machine can actually explain it in terms that humans can understand because there's no obvious terms. And so to some extent, you have to collaboratively come up with terms that expand the machine and humans vocabulary so that they can start using those in the later explanations. This is much farther down, but that's the kind of open-endedness collaboration actually means. I mean, there's this point that we have this evolutionary theory that we have the kinds of large brains that we have, not to run away from the tigers and the lions, but to deal with each other. And we basically developed this because we had to collaborate and compete with each other. And by the way, compete and collaborate are just two sides of the same coin. Whatever we do in collaboration, we can invert it and do compete. The inverse of collaboration is not competition, it's indifference. I don't even know that humans exist, which is basically what AI systems mostly tend to do. And that's what we want to get away from when we're doing collaborative AI. So a couple more things along this line of the dialogue, the kinds of open problems that might come up. Sometimes there might be multiple humans working at the same time with a particular AI system. And so it needs to provide differing explanations to them. And then you may be able to actually keep track of their different models and provide customized explanations, concurrent requests, and providing interface abstractions that are relevant to the different users based on their roles is also an interesting example, interesting challenge. And this is another one where, in fact, the explanations themselves are always about other person's mind. Somebody was talking about the fact yesterday that having subject matter expertise and knowing how to teach it are not one and the same. But of course, they are not one and the same. That's why researchers doing teaching is such a lousy thing. That's how our colleges are full of very boring teachers, because knowing something doesn't at all help you explain it unless you have a model of the listener's mind and you're actually teaching to the model of the listener's mind. And so explanations too are the same. So you provide explanations based on what you think are the model of the user in front of you. So you should be able to provide tailored explanations. So for example, doctors provide explanations of their decisions in one way to their colleagues and in a very different way to the patients. And because they have very different levels of understanding, very different types of vocabulary that the two types of people winds up using. That's relevant to keep in mind. Again, the one thing that I mentioned earlier, that trust is something that you won't be able to get away from. And so the reason machines provide explanations is to increase the trust of the humans in the loop, that hopefully they know what they're doing. Of course, in institutions, you can tell people that thou shalt trust this system. So, in Navy, you can say all soldiers must start believing this system that we already paid a huge amount of money to this certain company and bought it already. it might work in the short term, but after a while, people basically will trust and continue to trust or not the system based on A, its performance, and B, whether or not when it makes mistakes, its reasoning is interpretable to them. And so this idea of doing behavior that engenders trust in the humans is going to be quite critical. And this is quite, you can't disconnect it completely from collaborative AI. So, of course, trust is unobservable, and doing the right ways of, giving an estimate of the trust people have in the system is going to be an open issue. And in fact, to some extent, trust brings up a meta-reasoning problem. I might sometimes do a problem in a certain way to just increase your trust in me so that you will start believing in my capabilities, so that you'll leave me alone, so that I can actually do it faster next time around. And this is something that humans do all the time. And so, it may very well be that this is the kind of thing that you would have to do to reduce the monitoring costs for the humans by allowing them to trust the system because of its competence. This one I won't go into. Yes, this one I'm not going to go into this, but basically when you are providing assistance, you do want to be able to provide assistance in such a way that people realize that they're getting assistance. So, and this becomes a very important issue in partially observable environments. I don't know how many of you remember the Hitchhiker's Guide to Galaxy, where they did post on the Proxima Centauri that the Earth will be bulldozed, and none of us apparently paid attention. And so they felt as if they have done their part in being assistive to us, and we still didn't see it. And obviously we laugh at it because they shouldn't have expected us to be able to see it. The other thing, one other piece that I mentioned earlier is when you are providing help, when the machine is providing help to the humans, it should take into account their limitations in terms of the policies. If you are suggesting a policy for a human to execute, you should take into account whether or not the human understands the differences in the states in the way the machine understands, and especially their partial observability might be different from the machines. And so you have to provide policies that are easy to interpret for humans. And sometimes that might mean that you provide a policy that is actually not as optimal according to the machine, but it is doable to the human. And so building a user-specific mental model of their capabilities winds up being important. Sometimes machines, in certain cases, may have to actually scuttle their own capabilities so that the humans in the loop can actually collaborate with them in the short term, because they will basically be more predictable, because they're reducing the amount of choice points that that behavior might present to the humans. And this is another thing sometimes we wind up doing just so that the collaboration can increase. These are things that you don't think of right away when you think of collaboration, but they are pretty much part of the bigger picture of the collaboration. So there, sometimes you may have to provide, the allocation decisions for the humans if you are actually talking about human teams, and a collaborative AI as a planner, which actually centrally allocates them. You need to provide explanations as to why you're providing those, suggestions and so on. And finally, this is not something that I'm particularly happy about, but actually this issue of where do you get the knowledge that the machine is using and the human is using. Some of the things that we can talk about if we are into this is basically use systems like the LLMs like GPT-3, for example, to see whether you can convert text-based stuff that's already present in the task domain into formal representations that can be used both by humans and the machines. So I'll end there, and I'll just come back and say the challenges of collaborative AI really are this mental modeling, common ground vocabularies, providing explanations, advice taking, taking human limitations into account, and engendering and maintaining trust. These are at least some of the challenges that you have to deal with. And I think we made some small parts, some small steps on some of them, but pretty much all of these are open issues that seriously are central to collaborative AI. And Jeff doesn't have to worry that maybe somebody will say this, everybody in AI is doing it. No, not everybody in AI is doing it, because AI systems don't necessarily care about collaboration all the time. Some parts of the AI currently are slowly getting interested in collaboration, cooperation, and that's when these sorts of issues come important. I'll stop there. Thank you.
Right. We have about a minute left if anybody wants to entertain a quick question. Otherwise, I know this chat's been going crazy with lots of thoughts, Raul. So that's for you to look over and address.
I feel like I'm drowning in a wealth of things trying to keep track of. There's a lot of cool things going on in the chat and over on the mural. So thank you all very much. This is really, I think we've really shifted things in the next gear today. So keep it up.
Well, so Raul, what happens if the human dislikes the information or recommendation or advice coming from the AI? Then what does the AI do?
No, basically, first of all, the compliance is going to be a very important aspect. So if the human doesn't take the advice, they can just ignore the advice, in which case, essentially, if they don't trust the machine and they don't even want to bother explaining why it is wrong, they might just ignore it, which means actually collaboration isn't going to happen. The more constructive scenario would be that the human will actually provide a reason. In some sense, that's an advice saying in these situations, this is the kind of decision that you should be making. And that advice improves the machine's model. So the next time around, it won't make the same mistake.
What happens to the machine when the human turns it down? Does it reconfigure its thinking on
That's basically what happens, right? Because when the advice is changing the machine's model, this is same thing that expand paper and Neurips last year. So the human decisions are changing the machine's internal model of both the task as well as the human's preferences. And so that will change its later behavior. That's what is supposed to happen in the overall collaborative scenarios.
So that could be dangerous if somebody wants intentionally to do it wrong things.
Krishna, collaboration, I basically say, I am very happy to say that I was ecstatic when my son could lie because I knew he had a working brain. Mental modeling is something that's a high level of intelligence. And of course, you can misuse it. The answer to that is not to say we won't deal with that sort of capabilities. The answer to that is ensuring.
I'm not saying that you just need to be careful. That's all.
Yeah, of course. I mean, pretty much every one of these things you need to be careful. The more you become more flexible.
Just like a blade, you can use it to do.
Yes,
anything,
exactly. Right? And then another way of thinking about it is, everything is a dual use technology and intelligence is the ultimate, right, tool. So it is ultimate dual use technology. And so I completely agree with you. In fact, there's a whole entire aspect of this. All of these can be turned around and say, this is how you deceive. Okay, because as I said, the opposite of collaborative AI is not competitive AI. It is indifferent AI, which doesn't even believe that there are humans.
We're going to have to cut you off here just so we can advance to the next presentation. Sure. But hopefully, like I said, there's lots of stuff going on in the chat, on the mural. So keep it going.
Thank you.